Hello guys, today I'm going to talk about the Euler Lagrange equation in an easy way. My name is John Ardile and let's start. This is the Euler Lagrange equation, a beautiful equation. It is a second order partial differential equation that has three elements to the left side of the equation and one element or term in the right side. The first element is the derivative with respect to time of the partial derivative of t with respect to q dot minus the partial derivative of t respect q plus the partial derivative of v with respect q. And in the right side, we have the q and c. Each term has a meaning. T represents total kinetic energy of the system. V represents the total potential energy of the system. Q represents the position, in this case, is the degree of freedom or DOF of the system. Q dot is the time derivative of the generalized coordinates. So Q dot represents the velocity, the derivative of Q, position, with respect to time. And Q and C represents the generalized non-conservative forces, and T represents time. Now, let's take an example. The example is free fall. There is an element with mass with a velocity represents that q dot, and q, that is the position respect the ground. The ground is the reference position. Here we have the equation of Euler Lagrange, but we only have one dot or degree of freedom. So in the equation, this subindex is eliminated. And for an ideal case, we don't have non-conservative forces like the pressure of air or something like this, or friction, or the friction, for example. The equation should be this, with zero at the right side and only one dot. The kinetic energy is represents or equal to 1/2 mq dot square, and the potential energy is equal to mgq. M is mass, g is gravity, and q is the position. The partial derivatives of each terms are the partial derivative of kinetic energy respect q is equal to 0, and the partial derivative of potential energy respect q is equal to mg. Now the partial derivative of the kinetic energy respect q dot or velocity is equal to mq dot. And finally, the derivative of this element respect time is equal to mq double dot, that q represents acceleration. If we replace the elements in the Euler Lagrange equation, we have mq double dot minus 0 plus mg equals 0. Now we can eliminate mass or reduce mass, and we have q double dot that represents acceleration. In this case, is equal to minus g, minus gravity. Approximately is equal to minus 9.81 meters per second square. how will a bowling ball and a sheet of paper or a feather behave if the acceleration of each element is equal, is the gravity approximately minus 9.81 meters per second square. We think that the bowling ball in the reality case arrive first than the feather or the sheet of paper. But the ideal case or the expectation is the equation that we use in the last slides. In the reality, we have no conservative forces. So in this case, the bowling ball arrive first, and in the ideal case, both arrive at the same time. Now we are going to watch a video about this. Thank you and see you later.